Okay, Assalamualaikum class. Very good afternoon. Today we will cover chapter 10, object behavior and object system. We will start with the object behavior first. As I mentioned in the previous chapter, especially on the object and class chapter. So every object have a name, state, and behavior, right? So object behavior normally we describe their uh, process, yeah, normally using the state chart diagram. Okay, before that, just to rewind what we have learned before. So when we in the analysis stage, we use the use case diagram. Yeah, so we use use case diagram to describe the system behavior and the requirement behavior. And after the use case, we do very comprehensive analysis. Yeah, we model the object through interaction diagram. Yeah, after we discover the object through use case analysis, we discover the interaction diagram. So the interaction diagram determine, yeah, the dynamic object in the system. So uh, when we define every object, so we need to model it. So we need to know which object is interact to other objects. So this called uh, object interaction, where we draw it in using in UML. We use the sequence diagram. Okay, so every stage and every diagram used by the UML have a purpose. Yeah? Like I said, the use case describe the use case diagram describe the system behavior. Interaction diagram determine the dynamic object. So what is the purpose of the state diagram? State diagram is to describe the behavior of the object. So each object we need to uh, describe their behavior. Yeah? Uh, okay. The object behavior uh, in a real project, so you it depend on the requirements, yeah, depend on the needs, or depend on the complexity of the application or your class, whether you want to describe in you want to describe further detail or not. So when you decide that you need to describe the object, example object A, so this is where you you need to use the state chart diagram, yeah, to describe it. So in UML, they use a state chart diagram. So this is an example of state chart diagram. Uh, so this state chart diagram is show a specific behavior of the object. So before you start use the state chart in order to describe your object behavior, you need to know the syntax of the diagram. Right? So object behavior, when you want to describe the object behavior using a state chart diagram, so normally state chart have a start. Yeah, this is a start and a stop state. So every object behavior, they have start and they have state. So like you run a program, so the program will start with initialization, right, process, and housekeeping. So housekeeping is stop file, or you terminate the file. So initialization, normally before you start the program, you need to initialize something. You set the variable into 0, you set the memory and so on, and then you process it. Then after that you stop. So this is a basic uh, state chart diagram. Yeah. Uh, I don't know whether uh, in other methodology, let's say you use a structured methodology. Example, waterfall design. You use a data flow diagram, right? And data flow diagram produce the module. And I don't think that the behavior of the object can be elaborated through the FD, or maybe they use a flowchart. So this is a lot of way how to describe the behavior of the application. So in UML they use state chart diagram to describe the behavior of the object. So since we are in the object-oriented development process methodology, we use our object-oriented approach to develop the system. So we have to describe the behavior by using the state chart. Okay, we continue with the state chart diagram. So I repeat, state chart diagram should be start with the start state, and this is a state chart. Uh, this is a state detail. Yeah. So this is a state transitions. So after the process met some certain condition, so normally the state goes to another state. Yeah. So in this simple diagram, they start, process, and then end. Okay. So basically, they have a start, and then you go to the state detail, state transition, and then state end. Yeah. So state transition detail and state detail. Okay. So when the state is start, so this is a state detail. Okay. So state detail consists of a name of the state, what are the condition of the object right now is initialization, and then so what the object need to do in the initialization, so they maybe do initialize the uh, the working storage, the data or the variable, whatever logic of your application you will state here. Yeah. So this is one example, initialize cost offering data. Example, set variable a equal to 0, equal to 9, or equal to something. Yeah. And then after that, this state go to the open state. So in order to go to the open state, so they have a state condition here. So this called state transition, add student or set count. So after do analyzations, so what are the transition state transition condition. So in order to perform the open state, so what are the condition that this state initialization have to meet. Yeah. So let's say initialize the x equal to 0, and then the transition is the state will continue to add the student into the course roster database, for example. And they have to open the file. Yeah, open the file, search the student informations, and if the student information is exists, then they start to add. Sorry, if the student information is not exist, then they will add the student. If the student information is exist, so they will update it. So it depends on the logic you need, logic that supposed to implement in your in meeting the requirement. Okay, so after you complete the open, then it might go to the cancel. Let's say when you open the file and the data is empty or the file is error, then the application and the logic will be terminated, and it go to the uh, cancel state. So you see this is transition state. Yeah, transition state said that the state need to cancel, then it go to the cancel state. Okay, so I repeat, yeah, in a first state is initialization. So initialization state will do some condition, then when it meet a certain condition, so it do some process and open the file and try to open the file, or maybe the file is corrupted, then it got a message to cancel, and the cancel state will be initiate, and the state continue to close state. Yeah, cancel, close, and it go to the stop state. So this is a, a, a simple process how you describe the object behavior. Yeah, let's say you have one object called the system. It's a controller. So you need to describe the controller behavior. So how it start, how it process, how it manage the condition, if else then. Yeah, and then from if else then where the state goes, uh, it, it go to state 1 or state 2, state 3, or terminate the process. It's some sort like the logic of the program. Yeah, so I guess that if you don't want to show your object behavior using state diagram, so you can, I think you can describe the object behavior using a plain language. Yeah, uh, like pseudocode. Yeah, you use a pseudocode or algorithm. So I think that approach is more easy than use the state diagram. Okay, okay, class. You understand what is the purpose of the state diagram and how to use the state diagram. Uh, and I repeat that the state diagram is to describe the state behavior of certain object. Okay, uh, I can say that you are not necessarily, or this object behavior description is not the compulsory in the project, but for documentation and for detailed documentation, I think uh, it should be implemented. Yeah, it should be use this approach. But from my experience in the industry, I never use a state chart diagram. So we normally use the pseudocode or algorithm to describe the behavior of the object or class. Okay, class, I hope you understand what is the state diagram. So this you can read by yourself. I don't need to explain. So you should understand what is the state diagram, what how the syntax of the state diagram is, start state, stop state, and what is the state detail, yeah, what is the state transition. Okay, so I can conclude here on the object behavior using state diagram. So the state diagram got state start, and they got I think five state in the state diagram. State start, start state, sorry, state transition, state transition detail, state detail, and lastly stop state. Okay, now we move to object persistence. So this is a common object, yeah, you always uh, manage while you do the use case analysis, while you try to discovering the objects. So object persistence uh, is not excuse to be defined, to be discovered, because any information, so you need to store something. Okay, so we go to the definition of persistence. So when you talk about object persistent, we call it they have two things, object and persistent. So what does it mean of persistent? Persistent is the ability of an object to survive in the lifetime of the operating system process, yeah, in which it resides. So understand, class? What is that? What does it mean? Persistent is refer to the object that can survive in the operating system or in the computer, in your computer, or in any type of processor. Yeah, and persistent is relevant for object with an internal state. So the state need to be retained between object deactivation and object activation. So in other words, object persistent is an object that has ability to survive over time in the computer operating system or storage, yeah, uh, a type of storage medium or devices. Meaning to say, uh, it should be able to store in the persistent storage, such as file system or in memory, or in the systematic format. Normally we use RDBMS, such as Oracle database, or you use MySQL and so on. So in other words, very easy to understand is when you talk about persistent in object, when you talk object, it's a class, yeah, class object. So the application, when you talk about application, is relate to the computer, right? So when you talk about object persistent, is something that you want to store information. You want to store something that you can retrieve over time. Yeah? You can retrieve anytime, anywhere, and you can store it. You can update it. Yeah. So this called object persistence. So it not temporary, but it can be a lifetime of the computer. Yeah. Why I said lifetime of the computer or operating system? Once your computer gone, so the data cannot be retrieved. Right. Uh, Except you do some backup, yeah, in external drive, so you can open in another computer. So this is called lifetime. This called object persistence. Okay, so how to select persistent storage class? So when you I relate to the software development process, how you develop the system. uh, Information is no excuse. So the reason of you develop a software is you want to keep the information, right? You want to keep and you want to analyze the information. Of course you need a storage to store the information. So the information need will be kept in lifetime, right? So you need to persistent storage. Persistent means uh, something that permanent, yeah, permanent. Okay, memory I think is also the persistent storage, but memory quite danger in storing the information. It not long last, yeah, long last. Okay, so back to the how to achieve persistent, and I would like to say that how you want to select the persistent storage. So when you do system development, first thing that you discover the object class name, uh, especially on the entity, right? The stereotype of object is entity. Entity is something that you keep the information, data or record, eh? And finally you create the table, or data storage. Okay, so how you want to select the persistent storage? Firstly, when you do when you model the requirement and then you discover the object and class, and then you design the system, you architecting the system, and then after you architecting the system, you know the loophole of your system, you know the length of process of certain requirements. And then of course you start from the user interface. For example, you go to the web server, and then the system will go to the database, and it is a process, it involves process to complete one transaction. So first thing that you need to consider when you want to select the persistent storage is the access time. Yeah, the access time mean is how fast that you can get the information. Yeah, let's say you want, let's say in clinical information system, when the patient go to the clinic, then he or she represent the my card ID or passport ID, and then how you want to retrieve the patient record, and how fast that you want to retrieve the record. Okay, if you don't mind the record can be retrieved in longer times, so fine, you can continue with using the file system. Yeah, manual file system is not a digital file system. Yeah, so you need to go to the uh, medical department, or medical store department record, and then you will find manually. So this is up to you how long you expect to get the information. So but in the recent time, so patient or people cannot wait too long. So some maybe hospital give a standard process during the registration is less than 3 minutes or less than 1 minute. So you need to to think about the persistent storage, which can retrieve your data very fast and within the 3 minutes or within 1 minute. So this is a uh, this thing that you need to consider. So of course you choose a local database, for example, or you use cloud database. You use memory, for example. All patient information stored in laptop memory. Okay. Second consideration is storage capacity. So when you want to select the persistent storage, you need to calculate the number of data grow every day, every month, and every year. So you know that, for example, when you go to hospital Kuala Lumpur, there are thousands of patients per day. So you just imagine how much data space that you require for one day. A thousand of patients waiting in the list, and after they discharged from the hospital, from the outpatient example, so the information need to be kept. Not only the text data, their image, for example, their radiology image, their laboratory result, result, yeah, all must be kept in the system. So you need to plan. Okay, the flash RAM, for example, is not appropriate for that kind of uh, huge data to be saved. Yeah, so you need to consider, maybe you use a relational database or uh, no relational database, yeah, or file system. But typically in recent software development, so people will use RDBMS or no RDBMS. Yeah, that means no SQL. Okay, so number three you need to consider is a system reliability. So how reliable your persistent storage that you want to use? Is it reliable to use a flash RAM only, or you use a external drive? Yeah, or is it reliable to use SD card? Is it reliable use RDBMS system such as MySQL, SQL Server, DB2, yeah, MongoDB, MariaDB, etc. So you need to study, do some research. What is the features of the database system and etc. Is it reliable? Is it supported? Is it can refer when you got problems? So number four is accessibility. Accessibility means if you choose flash RAM, is it easy to access through internet? Easy to access in anywhere or anytime? Okay. If you use relational database, is it easy to access around the world? Yeah. Is it the persistent storage that you choose is only accessible within UTM, for example, within the hospital, for example, or intra hospital? Okay. So this is thing that you need to consider. You need to consider uh, how to make sure that your application can work well. Yeah, not only make sure that your application is free of bugs, but you need to make sure that you got good support from the database. So because you cannot run away from the persistent storage. So this is a story of a persistent storage. Yeah. So when you talk about the implementation, Persistent storage is the file system, yeah, or relational database or object database or flash RAM. Or now we use no relational database, yeah, no SQL they call it. Okay, understand class. What is the persistent? Okay, so this is an example of the persistent data. Yeah, when you go to the website, some image is displayed, and actually the image store the bit and byte uh, of the image, of the photo, for example. I show to you. So this is a persistent data. When we save, they go to the database and save it. And when we require it, and then we retrieve and they display it. So this is a persistent data. Where this persistent data is kept, so the persistent data is kept in the persistent storage. For example, in Oracle database system, in MySQL database system, and etc. Okay, this is an example of data. Uh, yeah, this is an example of data. They have header, message header, they have a detailed data. So this is an example when when you press the data through internet application. So this data will be bring over internet, over HTTP protocol, sent to the backend, and backend retrieve this data, and then they will convert into the or saved into the database. Yeah. So this is a persistent data to be kept in the persistent storage. Okay, back to the design process. When you discover the entity stereotype of object, so all the entity is the candidate of your uh, table, yeah, your database, candidate of table or database. So after you got uh, your entity object class, then you need to map to RDBMS, and then you model the entity, and then you create the data dictionary, yeah, the attribute name, the size of the attribute, the data type, and then the features of the attribute, whether primary key or foreign key or index, etc. Then you create the table, yeah? You create the uh, script, yeah, to generate the table. Okay, so this is an example of mapping the relational database. Alright, so each of your class have attributes. So this attribute is owned by the customer, yeah, customer class. And this customer, when we convert into the storage, persistent storage, become a customer table. So what is the column? The column is an attribute that you define in your class attribute compartment. Okay, so name, address, discount, yeah, order. Then convert to mapping to the order table. You have delivery time, you have urgency column, and etc. So this is a clue, yeah, it's a clue how you discover your entity, where from the entity you map to the table, table or database, yeah, table inside the database, yeah. Okay, class, have you following, are you following? If you're following, it should be okay. So you know the process now. It's quite theory, but I have to relate that when you do the object analysis, from the process of discovering the object class through use case analysis, so that is very important process where you can discover your class here. And this is a process how you discover your candidate, your table candidate. So this is a process how you uh, define or discover your uh, system completely. Yeah. Okay, I want to relate that. Why you need to uh, focus on the three stereotype? Yeah, entity, board, controller, yeah, and user interface. Yeah, uh, boundary, because it help you to develop your system clearly. Yeah, so this is a process. Okay, class, are you following? So this is another example of mapping the relational database from the class, from your class diagram to the table. Yeah. Okay. So database behavior inside the class. Okay. See this one. So when you do the dynamic modeling of your object through interaction diagram, see the curriculum manager contact the course. Yeah. Course is a become a it become the DB course. Yeah. So this is a process. So I want you to know that this process is not waste your time. So actually it help you to understand how to discover the tables, the controller, and the boundary. Boundary is related to your screen. Yeah, how you want to create the screen. What type of page that you want to develop. So this is all the idea is come from the sequence diagram and also the use case analysis. This is a what they call it output from the use case analysis. Okay, state diagram is important to describe the state of the certain process. A state diagram is not a compulsory tool to be used for modeling the algorithm. Like I said, that you can use pseudocode or algorithm to explain each of your object. Yeah. Use English plain is more easier. Uh, uh, Not only easier, but it's a detail. Yeah, but sometimes diagram cannot tell you everything. Uh, if you take arts or history, is okay. So you show a diagram, then you can remember what date, what years the World War happened. Yeah? When you show the picture, so you remember, or you are in the UK or in Europe. But in technical, in software development, it must be state even one dot. Yeah. So if you forgot to put a dot, then your system will looping forever. So that's why pseudocode I think is more practical. Or algorithm is more practical to describe the behavior of the object. Okay, persistent storage keep information and data to be updated or retrieved in the future. So chapter 10 covers state diagram and also uh, the importance of persistent storage. Yeah. So how you want to define or create your persistent storage. So you need to look at your class diagram where it owned by the stereotype of entity. Yeah. So that's why I asked you in last lecture in software architecture. So you need to create certain, or you need to design or construct your package diagram. Yeah, to group this kind of class into certain package where you can manage it easily. Okay, so I hope you understand what is the purpose of state diagram and what is the persistent storage. Again, I repeat, the state diagram is a UML notation to describe the object behavior. Okay, so what is the object behavior? The process, the inside process of your application. So object or class is your program. Yeah? So you need to visualize and you need to explain the internal process of your application. So what is a persistent storage? Persistent storage is an object that has ability to survive over time in the computer or storage device. Okay, so this is a high level meanings, but in term of technical is relate to the database. Database which consists of several various table. Okay, if you use RDBMS, if you use file system, maybe they call it text file and so on. Okay, class. I think that's it for chapter 10. See you later. Thank you very much and salam.